Boston Dynamics officially unveiled Atlas Gen 2 immediately after discontinuing Gen 1. With no more hydraulic drive system, this new humanoid robot will overhaul both its design and operation to directly compete with Optimus Tesla. Following the failure of Gen 1, Atlas Gen 2 may be commercially at a shocking price. The race for humanoid robots intensifies with both Gen 2 contenders. So, who's going to change the robotic game? As predicted by many, Boston Dynamics' decision to cancel the Atlas robot likely meant that they were preparing to release a superior replacement. And just one day after announcing the cessation of Atlas robot development, Boston Dynamics immediately declared that they were about to unveil a completely different generation of humanoid robots, still under the old name Atlas. How is the design of Atlas Gen 2 keeping up with Optimus? If the Tesla bot Gen 2 undergoes significant improvements in appearance and materials, enhancing its refinement compared to the previous generation, then Atlas has completely ditched its old design to debut the form of a more refined humanoid robot. The new version of the robot's almost unrecognizable as it didn't inherit any features of the old one. Gen 2 shed its bulky body, curved legs, and armored shell. There's no exposed cables anywhere on the new, sleek mechanical frame. Similar to bipedal robots like Tesla's Optimus, the new Atlas now features longer limbs, a straighter back, and a separate head that can rotate when needed. The biggest highlight here is that the face includes a built-in ring light. When Atlas stands upright, it does so when facing the camera. Now its head rotates around 180 degrees before its body follows suit. It stands still for a moment, giving the camera a clear first look at its head, a ring light forming the circumference of a perfect circle. The head of Atlas Gen 2 is one of the design elements that Boston Dynamics shared that they were quite concerned about. While every other robot's got a human-like head shape, the robot's head resembles a makeup mirror. Indeed, Boston Dynamics wanted it to stand out to create a friendly and approachable feel for anyone seeing it. This unique head provides a palette for the screen. Of course, there are sensors embedded within it, but the shape also serves to signify friendliness. This will be crucial for interacting with these in the future, and that's exactly what the CEO of the company shared. Compared to the previous generation, Atlas Gen 2 looks extremely modern this time. Boston Dynamics has taken a futuristic direction with this new design, learning from Tesla. At first glance, the appearance of robots may seem unimportant, but for us, especially as they start showing up in households, we think that Boston also considers this because at least no one would dare to buy a robot with a threatening appearance that might scare children. How did Atlas Gen 2 change its operating way to compete with Optimus? Boston Dynamics seems to have devoted considerable time to researching and developing Atlas Gen 2 before deciding to terminate the previous one. This is most evident through the transition to a fully electric robot design like Tesla's Optimus, rather than using hydraulic fluid in the drive system like before. Now, the new race truly begins because both of these robots primarily operate on the batteries provided by the manufacturer. Speaking of Boston Dynamics' previous robot, everything's different now. The previous version of Atlas did use electricity, but also relied on hydraulic fluid, as you can clearly see in the videos Boston Dynamics puts out. The hydraulic drive system brought many benefits to Atlas's robot, including a strong force, easy control, high efficiency, and agility. However, the drawbacks outweigh the benefits significantly, especially the most obvious ones like noise, fluid leakage, complexity, cost, and high adaptability. You can see the scenes of these robots emitting smoke when they fall, which is quite dangerous. Boston Dynamics made efforts to address these drawbacks, but was unsuccessful. More accurately, from the outset, the hydraulic drive system was a misstep because no customer appreciates a robot that's both loud and dangerous. Looking at Optimus, Tesla made a significant decision by not adopting a hydraulic drive system like Atlas did, even when they were just stepping into robot manufacturing. Optimus operates entirely on electricity, powered primarily by a 2.3 kilowatt-hour battery pack Tesla introduced. In comparison to the general landscape, this battery pack size is quite large because other robots on the market typically have battery packs below 1 kilowatt-hour. You know, Tesla has an advantage over other robot manufacturers because they excel in battery technology and have abundant resources. On average, a 2.3 kilowatt-hour battery pack can allow the Optimus robot to operate continuously for at least 8 hours on a single charge. It's really good to see Boston Dynamics transitioning from hydraulic or spark-driven robots to the entirely electric-powered version of Atlas. Like Optimus, this new robot operates entirely on electricity, which is truly fantastic. The all-electric Atlas robot will be significantly stronger, boasting a broader range of motion than its previous hydraulic counterpart. The new vision will build on older Atlas robots' capabilities of lifting and maneuvering a wide variety of heavy, irregular objects. We are continuing to build on those existing capabilities and are exploring several new gripper variations to meet a diverse set of expected manipulation needs in customer environments, the company revealed. What new tech does Atlas Gen 2 use to compete with Tesla Bot? In the early days of Optimus's public appearance, when Tesla robots seemed like just a person wearing a t-shirt, the CEO spoke of a system that could do it all. Your Optimus could work all day in a factory, do grocery shopping, cook dinner for you. It seemed like another Elon exaggeration. But what Optimus is showing now has proven its potential to some extent. The Tesla Bot has been quite well-rounded in all aspects. And what Tesla's focusing on now is just how to upgrade and maximize the utility that Optimus can provide. As for Atlas, although it's only been unveiled for a few days and Boston Dynamics has not yet disclosed the tasks and jobs this robot can do, some integrated technologies can demonstrate its potential to compete heavily with Tesla's robot. According to what Boston Dynamics shared, the old version of Atlas was already capable of lifting and controlling various heavy objects, irregular objects, and they are continuing to develop Atlas Gen 2 based on those existing capabilities, even checking out some new gripper variants to meet diverse expected operational needs in customer environments. According to official information from Boston Dynamics, the new version of Atlas is integrated with new machine learning and AI tools, such as reinforcement learning or machine vision, to move flexibly in the context of various variables of everyday life. In contrast to Tesla's approach of basing Optimus on the essence of human beings, Boston Robotics has chosen a completely different direction. Boston Robotics believes that limiting Atlas Gen 2 according to human body standards is dull. Instead, they believe in optimizing the functionality and performance of the machine by creating motions and parts unlike those of humans. One clear evidence of this perspective is Boston's choice to use only 3 fingers on Atlas Gen 2 instead of 4 or 5. While many might argue that the flexibility and diversity of 4 to 5 fingers would be the better choice, the company's CEO noted that there's a lot of complexity in a hand. And when we face the world with sensors, we got to prepare for reliability and robustness. Therefore, Boston Dynamics designed the Atlas robot with fewer than 5 fingers as a way to control their complexity. If Optimus Tesla integrates up to 8 cameras and multiple sensors, Atlas Gen 2 is not far behind. The way we understand it, it's equipped with various types of sensors, including cameras, LiDAR, and force sensors that allow the robot to perceive its surroundings in more detail and accurately. This allows the robot to do complex tasks like grasping objects, moving in tight spaces, and avoiding obstacles. With Atlas Gen 2, reducing the robot's turning radius is significantly also in cramped spaces. Remember, these machines are designed to be solutions for existing industrial environments, meaning they're designed to be integrated into current workflows in existing spaces. The ability to move more flexibly may ultimately be the difference maker between working within an environment and having to reconfigure. Why is movement speed such a big obstacle in robot racing? In its YouTube introduction video, Atlas Gen 2 starts off in a prone position on the floor before bending its legs backwards in an unusual manner, then puts force on its hip joints, which can rotate fully to stand up. It then demonstrates some pretty impressive movements. This time, Optimus seems to lag behind when it comes to movement speed compared to Atlas Gen 2. It's a fact we have to acknowledge when it comes to Optimus. Agility and speed of movement are not its strong points. With a speed of only 0.6 meters per second or 1.34 miles an hour, Optimus is still in the process of development to improve. Although it has been improved by Tesla's engineers by an additional 60% compared to its first movement capabilities. However, compared to similar competitors, Optimus still can't achieve the flexibility and impressive speed expected. On the contrary, Atlas used to be one of the fastest humanoid robots on the market before, and when compared to Optimus, the disparities get even more apparent. In the old Atlas version, with a speed of up to 5.5 miles an hour and the ability to perform incredibly agile runs, jumps, and even flips, it showcased some remarkable agility. However, from a safety and balance perspective, the way the first-generation Atlas moved was perceived by many as quite clumsy and prone to falls. Therefore, with its new version, Boston Dynamics has managed to make its robot move more slowly, seeming more stable. The manufacturer has not yet disclosed the specific speed for Gen 2, but it's easy to see that it still inherits some of the nimbleness of its predecessor. Even when it moves, it can rotate and pivot like a bizarre hybrid of a cab and a contortionist. Overall, despite being newly manufactured, the new generation still retains the strength of very fast speed, although its steps may still remind one of the confidence bordering on the brashness of the Spot Dog robot. The new generation of Atlas is more agile than before, even designed by Boston Dynamics to perform feats that are impossible for humans. We built a set of custom, high-powered, and very flexible actuators at most joints, CEO of Boston Dynamics Robert Plater shared about the new generation Atlas robot. That's a huge range of motion. That really packs the power of an elite athlete into this tiny package, and we've used that package all over the robot. Electric humanoid robots like Atlas will begin working in Hyundai factories next year, but the price has not been disclosed by Boston Dynamics. It'll become Boston Dynamics' third commercial robot, following the Spot Dog and Stretch robot specialized in box handling. How will Optimus and Atlas Gen 2 be commercialized? While old Atlas was not commercialized for many reasons, this time Boston officially announced that it would sell its new generation humanoid robot. Boston Dynamics will work closely with various customers, most notably Hyundai. The Korean automotive giant's next generation of automotive manufacturing capabilities will serve as a testing ground for new Atlas applications. This is the first look at a real product, but certainly not the last, the company emphasized. Similar to our Stretch rollout, we'll be partnering with a small group of innovative customers, beginning with Hyundai, to test and iterate Atlas applications over the next few years. It's surprising that the new Atlas will be tested with a small group of customers in the next few years, starting with Hyundai. This is pretty rapid progress for a new robot. However, we still think it'll come with a fairly high price tag, not much different than the old Atlas. Information about the selling price of the previous version of the Atlas robot manufactured by Boston Dynamics caused shock when leaked, reaching up to $150,000. That's an impressive figure, evidence of the advancement and complexity in humanoid robot manufacturing technology like Atlas. However, this is just the first step. Boston Dynamics continues to improve Atlas, aiming to provide even superior capabilities, striving for higher perfection in motion and information processing. And this will certainly lead to a higher price for the new version. The price increase may stem from various sources. One part's development of new technologies, from eliminating old production lines to creating new, more advanced manufacturing parts to fit the upgraded Atlas. This requires significant time and resources from scientists and engineers. Atlas also uses higher quality components, not only to increase precision, but to enhance performance, contributing to increased manufacturing costs. The assembly process of Atlas also requires meticulous and high expertise, further contributing to production costs. But despite the potential price increase, the progress and scalability of Atlas Gen 2 will make every dollar spent on it worthwhile. Meanwhile, Elon has confirmed at least twice that its price will be around $20,000 or even lower the first time at the AI Day 2022 event, where he said,
It is expected to cost much less than a car.
I'll just bring it directly to the right here.
I would say probably less than $20,000 would be my guess.
And most recently, as Tesla is expanding its advertising campaign for their robot ahead of its launch, Elon Musk continues to share on X that complexity per unit mass is much higher with humanoid robots, but I still think it ends up costing less than half a car. Therefore, with two instances hinting at Optimus's price dropping so low, there's no reason for Tesla to release a robot at an excessively high price point that would turn customers away. From some perspectives, we can believe that Tesla's mastered cost control at present, which is why Musk can confidently make such statements. Considering that Tesla's most popular car currently, the Model Y, has a starting price of $43,990 in the US, the CEO seems to be implying a price range below $20,000 to $25,000 for Optimus. Above all, Boston Dynamics' complete overhaul of their humanoid robots operation is commendable. Indeed, the transition from hydraulic to electric motors is no small feat and has significant implications in terms of cost, design requirements, and performance. Even Boston Dynamics acknowledges that hydraulic transmissions are outdated. While hydraulics rely on fluid and pistons to operate and move machinery, electric motors rely on electrical energy to rotate and move components directly. Electric motors tend to be cheaper, quieter, lighter, and less complex than hydraulic systems, but they may also wear out faster and be more susceptible to damage, while not providing the same load-bearing capacity or durability as before. This could be both an advantage and disadvantage for both Optimus and Atlas Gen 2 robots. Faced with the debut of Atlas Gen 2's futuristic designs, there have been debates over whether Boston Dynamics is trying to create a Terminator rather than a Tesla. This may be just a jest, as many witness the significant changes brought about by a Boston Dynamics design overhaul. In reality, the essence of robots is not inherently frightening. It only becomes truly concerning when combined with those who seek to turn almost every new scientific breakthrough into a weapon and the potential of AI. In the world of humanoid robots, the race between rivals like Optimus and Atlas Gen 2 is becoming fiercer than ever. Each of these robots has its own strengths and limitations, and the decision to choose between them is by no means easy. For Tesla's Optimus Gen 2, the goal is to create an affordable product that's easily accessible to the general consumer. This would make it a more attractive choice than Atlas, especially in various applications. Integration with other Tesla products like electric cars and smart home systems also provides clear functional convenience benefits for users. Additionally, the humanoid design of Optimus Gen 2 makes it easier to access and interact with humans. However, Optimus Gen 2 is not without its drawbacks. With a relatively new company like Tesla in the robotics field, lack of experience may affect reliability and performance of the product. Furthermore, it's still in the development phase and not yet proven in real-world applications. Meanwhile, Boston Dynamics Atlas has built a solid reputation in the robotics field. With nearly 30 years of experience in developing advanced robots, Atlas is their flagship product. Its performance has been proven through the execution of complex tasks in real-world environments, and its reliability is high thanks to high-quality materials and thorough testing processes. However, Atlas is not without its drawbacks, such as its high cost and complex design, making maintenance and repairs more challenging. Additionally, its design is not optimized for integration with other products, limiting its flexibility. In this race, each option comes with its own pros and cons, and the ultimate decision depends on the specific needs and requirements for users and businesses. So, what do you think about Boston Dynamics' remake of Atlas Robot, and what do you expect from Optimus in the upcoming improvements? We appreciate your contributions. We hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Tesla Car World family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Like the heart provides energy to the body, the battery serves as the lifeline for the robot, acting as the essence of Optimus. Upgrading the battery capacity from 2.3 kilowatt-hours to 5 to 10 kilowatt-hours marks a significant leap, propelling Optimus to new heights. This revolutionary enhancement not only expands Optimus's operational capabilities, but also alleviates the burden of frequent recharging, akin to lightening the load on the heart. How has Tesla leveraged advanced technologies to enhance the performance of the Tesla Bot's battery pack? What battery technology does the Tesla Bot employ to stand out from other products on the market? Tesla's standout achievement has been its successful implementation of the Optimus production process over the past 8 months. By leveraging its understanding of human anatomy, Tesla has introduced a groundbreaking concept in creating a humanoid robot. This approach was crucial in crafting Optimus, a robot capable of interacting with its environment much like a human with 2 legs, 2 arms, and fundamental movements. Streamlining the core movements to under 30, excluding hands, Tesla has delivered a practical and efficient product. Now, let's delve into the intriguing details of the Tesla Bot's heart. Similar to a human body housing a heart, the robot's chest contains its power source, the battery. Initially, it was predicted that a single charge of a 2.3 kilowatt-hour battery would suffice for a day's work. All electronic components of the battery are integrated into a single circuit board within the pack. This technology aids in managing charging and distributing power in one place. Drawing insights from vehicle and energy production processes, Tesla developed a battery type that allows for rational manufacturing along with simple and efficient cooling methods. With integrated electronics, it's perfect for a full day's work. It also consumes around 100 watts when idle and 500 watts when walking briskly. The actual power consumption is not overly significant. According to CNET's observations, Optimus Energy's consumption is quite similar to that of a high-end gaming PC, with the caveat that this robot moves on 2 legs, performs all physical tasks, and weighs 160 pounds. Perhaps after 2 years, a 5 to 10 kilowatt-hour battery capacity would be a reasonable choice for Optimus when upgraded. This capacity provides operating times of around 20 to 40 hours, meeting the needs of most routine tasks. Moreover, it helps maintain efficient balance and constraints, ensuring Optimus operates flexibly, cost-effectively, and suits various usage environments. Charging time for Tesla Optimus with a battery capacity of 5 to 10 kilowatt-hours can be expected to increase proportionally with larger battery capacities, 2 to 4 times that of a current 2.3 kilowatt-hour battery. However, an exact figure cannot be determined as charging time depends on various factors. Charging power is a crucial factor affecting charging time. With higher charging power, charging time will be reduced. Example, a 5 kilowatt-hour battery and a 250-watt charger, estimated charging time could range from 2 to 3 hours. However, if using a 500-watt charger, charging time could be shortened to 1 to 1.5 hours. Charging efficiency also plays a significant role. Higher charging efficiency helps minimize energy waste and thereby reduce charging time. Utilizing advanced charging technology and efficient battery management can significantly improve charging efficiency and shorten charging time. Currently, Tesla remains cautious about disclosing the type of battery that it'll use for Optimus. However, based on patents, predictions, and market analysis, it's highly likely that Tesla will choose lithium-ion Li-ion batteries. Simply put, compared to NiMH batteries, lithium-ion batteries have 2 to 3 times the energy density. This means Optimus could operate from 8 to 12 hours with just a 5 kilowatt-hour battery, providing enough power to complete tasks like household cleaning, cooking assistance, gardening, etc., without the need for frequent recharging. The advantage of being 20 to 30% lighter than NiMH batteries helps Optimus move more flexibly, save energy, and operate more efficiently, especially in complex environments. As a result, Optimus can easily navigate through narrow spaces in the home, climb inclines, or move on rugged terrain without difficulty. The average lifespan of Li-ion batteries is 5 to 7 years, longer than that of NiMH batteries, 3 to 5 years. This helps Optimus accompany users for a longer period, save battery replacement costs, and significantly reduce electronic waste. As the most common type of battery today, Li-ion batteries are easily manufactured in large quantities and provide reasonable costs. Manufacturing Li-ion batteries in large quantities helps Tesla reduce the cost of producing Optimus, thereby delivering the product to consumers at a price point of $20,000, making Elon's household robot much more competitive in the market. CATL's currently leading the development of LFP batteries and is a supplier of high-safety battery types with long lifespans. It's known that Optimus has a 2.3 kilowatt-hour battery, slightly smaller than the 3 kilowatts of Boston Dynamics' Atlas. However, it's expected that Optimus will be able to operate continuously throughout the day with just one charge, surpassing Atlas with continuous operating times of only 20 minutes or light movement within 1 hour. The Tesla bot demonstrates remarkable energy efficiency, consuming only 100 watts when idle and 500 watts when moving quickly. In contrast, there is no specific information available on Atlas's energy consumption. Additionally, Optimus uses a lithium-ion NMC nickel-manganese cobalt battery with integrated electronic devices on a single circuit board, optimized for production and cooling processes. Meanwhile, Atlas uses lithium-ion polymer batteries with separate battery management systems. How does Tesla enhance the battery performance of Optimus to deliver exceptional user experience? Tesla's Optimus battery boasts impressive efficiency in doing daily tasks thanks to its efficient energy consumption and large capacity. With average energy consumption equivalent to slow walking or idle standing, Optimus can operate for over 20 hours for tasks like cleaning the house, cooking, laundry, and other common chores. This enhances convenience and efficiency for users in carrying out daily tasks without worrying about recharging. In the medical support field, where slower movement and less energy consumption are needed, Optimus can still operate for over 10 hours. This makes it an ideal choice for assisting the elderly, disabled individuals, and other medical tasks requiring continuous care and monitoring. However, in the construction field, where frequent movement and heavy lifting are common, Optimus can only operate for 4 to 5 hours. Nevertheless, with its ability to support enhanced labor, it can still reduce effort and time for construction workers in performing difficult tasks. Optimus, the robot from Tesla, is not just an ordinary machine. It's a complete system equipped with a 2.3 kilowatt-hour battery, equivalent to a small electric vehicle. Although this figure seems significant, it's worth noting that the utilization efficiency reaches only about 80%, meaning only about 1.84 kilowatt-hours of actual energy can be used for its activities. Optimus is not a rigid robot with fixed energy consumption. In fact, its energy consumption varies depending on the type of task assigned. When idle, Optimus consumes about 100 watts, equivalent to turning on an energy-saving light bulb. With a current battery capacity, it can operate continuously for 18.4 hours when sitting still. When moving slowly, energy consumption increases to about 200 watts, allowing the robot to operate for 9.2 hours. Faster movement, such as brisk walking, increases energy consumption to 500 watts, reducing operating time to 3.68 hours. When running, Optimus consumes 700 watts, and when carrying heavy loads, energy consumption can hit 1,000 watts, limiting operating time to 1.84 hours. However, these numbers are estimates, and actual figures can vary depending on several factors, like activity intensity, terrain conditions, weight of the carried items, and even temperature of the environment. A notable point here is that Optimus is not just an energy-consuming machine without consideration. It uses optimization algorithms to adjust energy consumption levels appropriately for each specific task, thereby helping to extend the robot's operating time. Compared to Boston Dynamics' Atlas, another competitor in the market, Optimus truly excels in continuous operation capability and prolonged working time. Atlas can operate for about 20 minutes continuously or 1 hour with light movement, While it may be suitable for short-term tasks requiring flexibility and high mobility, Optimus is better suited for long-term tasks requiring continuous and stable operations. This brings significant benefits to various industries and applications, from household to medical, construction, and lots of other fields. Both Optimus and Boston Dynamics Atlas utilize lithium-ion batteries with an expected lifespan of approximately 5 to 7 years. However, to gain a deeper understanding of the actual lifespan of the batteries in these two robots, several critical factors need to be considered. When discussing battery lifespan, an important factor to consider is the battery's charging and discharging capabilities, as well as how the robot's used in its operating environment. Optimus, with its longer operating time per charge compared to Atlas, clearly has an advantage in extending battery life. Less frequent charging not only helps reduce battery wear, but also decreases the cost and time required for recharging. This is particularly crucial in medical or industrial applications where the robot's continuity and stability are paramount. While both robots perform best in stable environmental conditions with average temperatures, overall, environmental temperatures do impact battery lifespan. Sudden temperature fluctuations or extreme hot or cold environments can cause rapid degradation and decrease battery performance. This needs to be carefully considered when deploying robots in harsh or unstable environments. Additionally, usage patterns can also affect battery lifespan. Adhering to manufacturer guidelines and usage procedures not only helps minimize battery degradation, but also ensures the robot's optimal performance. Regular maintenance and upkeep are also important factors in extending battery life and ensuring the robot operates reliably over time. How does Tesla's battery upgrade for Optimus influence its retail price? The initial price of Tesla Optimus AI robot could be around $20,000, but Tesla aims to reduce the price as they make more. They want to make it affordable for everyone. As they manufacture more robots, costs may start to decrease, making it easier for more people to access this advanced technology. Tesla is striving to bring advanced robots to everyone, hoping to help a broader range of people access them by making them more budget-friendly over time. Upgrading the battery capacity from 2.3 kilowatt-hours to 5 to 10 kilowatt-hours will result in significant changes to the price of the Tesla Optimus. It's expected that increasing the battery capacity will come with increased production costs, especially regarding the battery. Based on predictions, the cost of the battery could increase by around 50 to 100% when upgrading to 5 kilowatt-hours and over 100% when upping to 10 kilowatt-hours. This is because higher capacity batteries will require more materials and components in the production process, along with the development of higher capacity battery manufacturing technology, and that demands more complex technologies and processes. The biggest impact will come from adjusting the price of the Optimus. It's anticipated that the price of the robot could increase proportionally to its battery cost. With the battery capacity increased to 5 kilowatt-hours, the price of the Optimus could increase around $50 to $100, equivalent to 2.5 to 5% of the original price, which is $20,000. For larger battery capacities like 10 kilowatt-hours, the price could go up by over $100, equivalent to over 5% of the original price. However, increasing the price could affect the product's competitiveness. Tesla needs to carefully consider the balance between improving the product and maintaining competitive pricing in the market. This is especially important in the context of competitors offering lower-priced alternatives in the market. In the future, Tesla's decision on increasing the battery capacity and adjusting the price of the Optimus will depend on market demand, pricing strategy, and competitive capabilities to optimize both performance and product value. What technology has Tesla integrated from EVs into Optimus to enhance the robot's performance? By integrating electric vehicle technology into Optimus, Tesla's brought about a revolution in the capabilities of this advanced robot platform. Moreover, Optimus's brain will leverage Tesla's expertise in chip design. Thus, each humanoid robot will have a Tesla SoC. In terms of connectivity, Optimus will have both Wi-Fi and LTE. This will enable Tesla to update and improve Optimus's performance over time quite easily, similar to the way the company updates its fully electric vehicles. Automobile manufacturers often update their software via internet connectivity, which can improve performance, fix bugs, and add new features. Tesla can update and enhance Optimus's performance over time through internet connectivity. For example, Tesla could add new features such as facial recognition, natural language communications abilities, or the ability to control smart home devices. Optimus is equipped with a range of advanced sensors, including high-res cameras, LiDAR, radar, force sensors, and position sensors. These sensors provide the robot with the ability to accurately perceive its surrounding environment and interact with objects delicately. High-resolution cameras allow Optimus to accurately recognize even small objects, while LiDAR helps create detailed 3D maps for navigation and obstacle avoidance. Radar supports the detection of moving objects, ensuring safe movement in crowded environments. Force sensors enable Optimus to measure forces acting on its parts, facilitating precise manipulation and interaction with objects. Additionally, position sensors track joint movements, enabling precise coordination and control of movements. Optimus's drivetrain system is robust and flexible, including servo motors, pneumatic drive systems, and hydraulic drive systems. Servo motors provide precise and controlled movements, while pneumatic drive systems deliver powerful and rapid movements. Hydraulic drive systems provide high force and torque for tasks requiring precision, like lifting heavy objects and performing strenuous activities. In terms of control software, Optimus utilizes a modular control system that divides control tasks into manageable modules, enhancing overall performance and reliability. Machine learning algorithms allow the robot to learn from sensor data and control inputs, improving performance over time and adapting to new environments. Additionally, artificial intelligence is used for planning and decision-making, enabling Optimus to automatically perform complex tasks. Optimus's capabilities are impressive, evidenced by its ability to detect small objects, move quickly, lift heavy objects, learn new tasks, and automatically navigate in complex environments. Through the integration of advanced sensors, powerful drivetrain systems, and intelligent control software, Optimus achieves superior functionality and flexibility across various applications. The evidence provided highlights extraordinary capabilities of Optimus. Equipped with advanced sensors, it can recognize and interact with objects as small as a few millimeters. Furthermore, Optimus demonstrates outstanding agility, reaching speeds of up to 20 kilometers an hour and easily overcoming obstacles up to a meter high. Its impressive strength is evident in its ability to effortlessly lift objects weighing up to 200 kilograms. Additionally, Optimus's ability to learn new tasks by observing human gestures and autonomously strategizing for movements in complex environments highlights its adaptability and intelligence. Moreover, Tesla's shown what the robot sees, and it looks very familiar. That's because the neural network is directly taken from autopilot. Training data had to be collected to show settings indoors and products not used with cars. Engineers have trained neural networks to identify high-frequency features and key points in the robot's camera string, such as charging stations. Tesla's also used the autopilot simulation engine, but integrated it for use with a robot program. The body also contains a centralized computer that Tesla says will do everything a human brain can do, like processing visual data, making split decisions based on multisensory inputs, and supporting communication. Additionally, the robot's equipped with wireless connectivity and audio support. Indeed, the robot will have conversations. "We really want it to be friendly, practical, and also a companion you can hang out with," Musk said. Tesla's autopilot software has been transferred from cars to robots and re-equipped to operate in a new body and environment. Tesla's footage captures scenes of people performing tasks in the real world, like lifting a box or using inverse kinematics, repeating movements with Optimus. Then, online motion adjustments applied to make these tasks not too rigid and controllable to account for non-structured environments. As we eagerly anticipate the progress of the Tesla Bot Gen 2, expectations are high for the improvements it'll bring, especially with the introduction of a new battery pack that promises longer operating times and lighter weight. With Tesla's track record of innovation and commitment to pushing the boundaries of technology, expectations for this next generation of robot assistants is very high. And we look forward to the unveiling of the Tesla Bot Gen 2 and experience the benefits of its advanced new battery technology. We hope for a future where robots seamlessly integrate into our lives, providing greater efficiency, convenience, and productivity. The dawn of the Tesla Bot Gen 2 marks a new era of robots, where extended operating times open up opportunities for even more applications and breakthrough capabilities. We hope you'll experience the utmost relaxation after watching this video. If you do, please press the like button and join the Tesla Car World community by subscribing to our channel. Hit the notification bell icon to stay tuned for any fantastic videos coming your way. Your feedback and time are highly appreciated. It won't just stop at an Optimus Gen 2 moving 50% smoother and featuring a completely redesigned arm with 11 flexible joints. Especially the integration of precise touch sensors on each fingertip brings about the ability to interact with the surrounding environment delicately and efficiently. It's precisely these upcoming superior enhancements that have led Elon Musk, the ambitious CEO of Tesla, to assert,
"I think Optimus will be more valuable than everything else combined, because if you've got a sentient humanoid robot that is able to navigate reality and do tasks at request."
So, what other reasons might have driven Tesla's decision to introduce Optimus Gen 2 to the market in 2025? Why is Elon Musk confident in stating that Optimus could start selling next year? Recently, automobile manufacturer Elon Musk confidently discussed plans to use robots in his company's factories.
We are able to do simple factory tasks, or at least I should say factory tasks in the lab. In terms of actually, we do think we will have Optimus in limited production in the factory, in the actual factory itself, doing useful tasks before the end of this year.
Naturally, this step is highly praised and with good reason. Tesla is actively testing and refining the Optimus robot at Gigafactory plants, marking an important and first step in the upgrading and perfecting process, especially in terms of Optimus's dexterity. Although the exact number of prototypes is not disclosed, many sources suggest that there could be dozens or even hundreds of Optimus units deployed. The testing phase covers various tasks, from transporting heavy and bulky parts to assembling small components, using tools, and inspecting product quality. Particularly with the ability to transport heavy loads of up to 90 kilograms, handle small detailed tasks with hyper precision, and flexibly use handheld tools, Optimus is performing quite well and promises to reduce the risk of workplace accidents, automate dangerous and mundane tasks, and improve product quality. According to Elon Musk, Optimus is now capable of moving like a human and performing basic tasks. However, this robot still needs further improvement in environmental perception and complex operations to better complete assigned tasks before being introduced to the market. This testing and refinement phase plays a crucial role in ensuring the efficient and safe operation of Optimus before widespread deployment in Tesla's factories. Elon Musk highly values this development, stating, "If you have a humanoid robot that has tri-vision and can navigate the real world and do useful things, then there's no limit to what economic value you can have." So that's what's going to happen, and I think Tesla's best position of any company to achieve a very high-utility humanoid robot. The use of Optimus in the factory holds great potential benefits for Tesla, meticulously calculated and gradually quality checked for launch and sales next year. But even in the immediate future, Tesla stands to benefit from its brainchild in boosting productivity. Optimus can work 24/7 without rest, significantly increasing manufacturing productivity. Of course, in terms of cost reduction, Optimus can help Tesla save labor costs. The reduction of 10% of Tesla's workforce in several rounds of layoffs at Gigafactory Texas, New York, and Giga Berlin, especially totaling nearly 23,000 workers at Giga Texas, has been announced and is expected to save the company $1 billion in labor costs annually. Optimus can help Tesla achieve similar or even higher savings in the future. Additionally, Tesla's CEO has revealed Optimus Gen 2, a new generation humanoid robot capable of taking on repetitive tasks from humans. This is something many people have been wanting, as the new prototype shows many improvements over previous inefficient robot versions, providing a certain level of reliability for the project, something that was mocked when a dancer disguised as a robot was first announced to aid vision a few years ago. Equally important, Tesla believes that this can be achieved by leveraging its AI work and its self-driving car program, as well as its expertise in batteries and electric motors. It argues that its vehicles are already robots on wheels. Now it just needs to create them in a humanoid form to replace humans in some tasks, mostly repetitive and hazardous tasks. With recent companies betting on humanoid robots to address latent labor shortages and perform repetitive tasks that could be dangerous or mundane in industries like logistics, warehousing, retail, and manufacturing. He even confidently predicts that Optimus will capture a large part of Tesla's long-term value. Many experts estimate that Gen 2 bots will help Musk increase the value from $500 billion to $1 trillion US, which sounds unbelievable, but perhaps it will happen starting next year. Musk is confident that Tesla will solve the autonomy problem for vehicles with or without him. However, developing Optimus is another matter because it has its own risks. Earlier this year, Elon Musk stated that he wants to acquire 25% of the voting control at Tesla to ensure that the development process of Optimus is safe and executed properly. Of note, the robot maker is hotter than ever, as other big players in the field, including Honda of Japan and Hyundai Motors Boston Dynamics, have been actively pursuing advancements in humanoid robot technology for several years, pushing forward their upgrades even further. Moreover, there's been a recent surge in efforts to collaborate between technology companies and automotive giants to integrate humanoid robots into their operations. Recently, startups backed by Microsoft and NVIDIA announced a collaboration with German car manufacturer BMW to deploy such robots at the company's facilities across the United States. How does Tesla plan to deliver on its promise of achieving the price of Optimus below $20,000 by 2025? Elon Musk stated that Optimus, Tesla's versatile and humanoid robot, will be priced less than half the price of a car. To make that effective, they'll have to be reasonably priced. Musk previously said he thinks they can bring the price down below the company's cars, which typically starts at around $40,000. First, let's assess the flexibility of the Tesla Optimus Bot Gen 2, making purchasing a Tesla Optimus a worthwhile investment. Gen 2 is not just another robot, it's a game changer. With advanced sensors and AI, it can tackle a remarkable range of tasks, from supporting tired assembly line workers to serving as a surgical assistant or even a helpful household companion. The adaptability and superiority of Optimus Gen 2 make it a truly flexible investment for the future. Despite its affordability, the promise of Optimus Gen 2 being priced under $20,000 as suggested by Elon Musk indicates that this advanced machine could be used for both businesses and households. This revolutionary price point not only speaks to its capabilities but also to its affordability, potentially democratizing access to advanced robots for many years. Opening the door for Optimus Gen 2 to become a ubiquitous presence in our daily lives, Tesla's Optimus robot serves as a versatile household assistant. With the ability to fold clothes in 30 seconds and store them away, it can operate continuously throughout the day without rest. Powered by a 52-volt 2.3-kilowatt battery, weighing just 138 pounds in the Gen 2 version, it may not require battery upgrades due to reduced weight. Optimus can handle loads of up to 45 pounds with an 11-degree freedom angle and can even handle cleaning tools, control vacuum cleaners automatically, and make sandwiches, making it a flexible assistant in our daily lives. Tesla's Optimus robot can learn and improve after each use, from cleaning up after cooking to performing agricultural tasks like pruning and fertilizing, or even tackling complex manual tasks like medication dispensing. It also has educational features, such as reading books to assist children and helping elderly people manage conditions like Alzheimer's, as well as addressing everyday issues like light and power. Priced at $20,000, it's considered valuable for its initial capabilities aimed at repetitive tasks. Tesla bots are expected to serve millions of households, including cooking, lawn mowing, and caring for the elderly. The features of Tesla's robot significantly contribute to cost savings, making it a highly attractive investment for households, commercial enterprises, or large-scale factories. With the ability to perform various tasks, Tesla's robot becomes a versatile asset. It can fold clothes and handle large volumes of laundry, save money by performing income-generating tasks like delivery and manufacturing. The potential cost savings from using Tesla's robot can be up to $83,000 a year, with a return on investment in just 3.7 years. One of the biggest advantages of the robot is its ability to work 7,000 hours per year, providing a significant labor advantage over humans. Cost savings could amount to $25,100 over a 10-year period, allowing businesses to redirect resources towards higher-level strategic initiatives, driving innovation and creativity. Thus, overall productivity and efficiency of businesses will significantly increase with the deployment of Tesla's robot. Tesla's robot will be trained to manufacture other Tesla robots, initially deployed at Tesla's factories. This approach ensures scalability and enables the creation of a self-sustaining robot manufacturing ecosystem. By leveraging the capabilities of Tesla's robot, businesses can rationalize operations, reduce costs, and enhance overall production efficiency. Tesla's robot factory can save significant costs through various means, including reducing training costs at Tesla facilities. Establishing a neural network and accumulating thousands of hours of training data is a time-consuming process. However, by leveraging advanced artificial intelligence and machine learning capabilities, Tesla's Optimus robot surpasses humans in many aspects. It operates tirelessly, eliminating human errors, ensuring consistent task accuracy, and minimizing workplace accidents by handling dangerous tasks and adapting to various manufacturing situations. This contrasts with human labor and enables scalable deployment, enhancing overall production efficiency and achieving significant long-term cost savings. Tesla can ramp up production to meet the growing demand for vehicles and potentially exceed the target of 20 million vehicles by 2030 with the support of Optimus. In fact, the robot poses a competitive threat. Businesses need to leverage the significant cost savings that Tesla humanoid robots will bring. These robots need to be integrated into the workforce. According to C.N. Basher, CEO of large conglomerates with a large workforce, they should immediately be contacting Elon and making a significant payment to be the first to purchase the Optimus robot. They should not be at the back of the line. They may have to wait for years. Tesla has finally found its way to the assembly line at Tesla and other businesses. In fact, Tesla's maximizing the range of tasks it can complete by diversifying orders. Furthermore, to continue enhancing the efficiency of the Optimus robot, Elon Musk may push for the maximum use of AI technology and develop data processing and autonomous driving technologies with a goal to elevate the standard of self-driving artificial intelligence and optimize Optimus by integrating fully autonomous driving in combat with martial arts. This chip will surpass everything else currently on the market. He's also focusing on upgrading the electric motor of Optimus to make it a smarter and long-term solution for everyone's needs, with an expected price range from $20,000 to $25,000. He predicts Optimus will become popular in both households and companies. With this vision, Elon and his team have demonstrated that they relentlessly pursue opportunities to reshape the future with innovative ideas and relentless ambition. With Tesla's vision almost ready to introduce a product that could change the game in the robot industry as well as the field of self-driving cars, it's certain that Optimus, with its many features and diverse capabilities, will eventually accumulate a significant portion of Tesla's revenue. Long-term value. This is why Tesla's Optimus robot is an essential component of every household, providing convenience and security on a daily basis. Far beyond the role of just a standard domestic assistant, it cannot be denied that creating Tesla's robot will bring great benefits to humanity in the future, despite the limitations and untapped potential. What updates and upgrades is Tesla making to Optimus to expedite its market launch? Optimus Gen 2 surpasses and executing tasks with exceptional efficiency, not only demonstrating adept clothes folding or delicate egg handling, but also impressively showcasing an autonomous capability of 89%, dexterity of 99%, and human-like flexibility at 97%. Moreover, it suggests a feature where mass production is not only achievable but also imminent, evidenced by Tesla's recruitment announcement for engineers in the Tesla Bot program. Furthermore, Milan Kovac, head of Tesla's Optimus technical department, has elucidated some advancements achieved when Robot Gen 2 currently has the fastest walking gait ever, approximately 0.6 of a meter per second, a 20% increase in speed. Perhaps upon release, it could be perfected up to 80%. Both the forefoot system and foot trajectory and ground contact logic have been improved along with other enhancements. The team added a bit of sway to the torso and arms to make it look more natural. Elon Musk's announcement also serves as evidence of Tesla's firm commitment to pushing the boundaries of innovation, particularly emphasizing Optimus Gen 2's standout features with an impressive 11 degrees of freedom of movement. Equipped with a faster drivetrain and tactile sensors on each fingertip, this level of dexterity allows the robot to perform complex tasks with superior precision. Whether it's folding clothes or handling delicate objects, Optimus Gen 2 sets a new standard for what robots can achieve. It reminds us that just a few months ago, we witnessed a humanoid robot delicately handling an egg, demonstrating what it describes as assured tactile feedback on each fingertip. This performance highlights the robot's particular sensitivity and accuracy in object manipulation. Previously, Optimus took center stage by arranging colorful building blocks with remarkable precision. Optimus Gen 2 proudly boasts a neck with 2 degrees of freedom, allowing it to mimic human head movements with integrated precision feature, redesigned electronics and wiring systems to improve efficiency and performance. Regarding its robot feet, they are designed with human-like characteristics with articulated toes and torque sensors to enhance balance and overall mobility. In addition to its capabilities, the Optimus Gen 2 program also introduces a more human-like and aesthetically pleasing design than its predecessor's bulkier form. Standing at 5'11" and weighing at 121 pounds, a 22-pound reduction from the previous model, this weight reduction, along with a 30% increase in walking speed, allows this robot to move at a speed of 5 miles an hour with a 35-degree tilt. The freedom between various joints allows movement in multiple directions and angles, continuing to replicate its movements. Moreover, this improved aesthetic design, reminiscent of Tesla's Model S elegance compared to the initial clunky TR online form, makes the robot look and move more gracefully. With such remarkable advancements, Tesla not only redefines the capabilities of humanoid robots, but also paves the way for their wide-ranging applications, potentially competing with the athleticism of Boston Dynamics. Tesla's vision for Atlas extends beyond research and development to create humanoid robots that can serve the mass market. However, according to Elon Musk, the robot still does not autonomously fold clothes, at least not yet. Tesla clarified that they're working to enable Optimus to perform those tasks fully autonomously in any setting, eliminating the need for a fixed table with specific conditions if necessary. Tesla's humanoid robot is being highly regarded as it undergoes testing in the factory, with a successful completion of tasks prompting the company to expedite production quantities to be able to supply the market as much as possible and outperform competitors from day one of launch. There's so much anticipation for this robot when seen doing household chores, and that's what many of us are eagerly awaiting. How many people are ready to pre-order to own it? The allure of the Optimus seems greater than that of the Cybertruck pickup and might exceed 2 million pre-orders. What do you think? We hope you'll experience the utmost relaxation after watching this video. If you do, please press the like button and join the Tesla Car World community by subscribing to our channel. Hit the notification bell icon to stay tuned for any fantastic videos coming your way. Your feedback and time are highly appreciated. Tesla has quickly established itself as a key player, unveiling 3 generations of robots in just 16 months. With the recent introduction of Optimus 2, Tesla has sparked considerable interest and discussions regarding its potential competition with industry leaders like Boston Dynamics and Unitree H1. Despite Boston Dynamics' extensive 20-year experience, Tesla's innovative approach, particularly in AI-driven technology, hints at a promising future for its humanoid robot manufacturing endeavors. Why is Tesla Optimus confident it can surpass Atlas Dynamics in the robot race? Let's begin with the clash of titans as they embark on the quest to create humanoid robots. Boston Dynamics, a company born out of MIT's engineering expertise, initiated their revolutionary journey in 1992. Their early models focused on designing primarily quadruped robots, specifically tailored for military purposes. It wasn't until they introduced Spot, their first commercial robot, at a later stage. However, it wasn't until 2009 when the debut of Atlas, their first humanoid robot, truly captured the world's attention. With parkour abilities, lightning-fast leaps, and astonishingly agile movements, Atlas set a new standard for the future of the robotics industry. Not to be outdone, Tesla unveiled Optimus, their humanoid robot, with a revolutionary goal of mimicking human behavior. Although not as agile as Atlas, Optimus excels in vision, utilizing advanced sensors and Tesla's modern technology to accurately detect objects and navigate various environments effortlessly. The primary difference between Optimus and Atlas lies in their design, perception, and purpose. Optimus resembles humans more closely, employing AI-based cognition and aiming for commercialization. On the other hand, Atlas focuses on physical skills and is primarily designed for research purposes. The design and size of a robot play a crucial role in determining its capabilities and practical functions that the manufacturing giants want to emphasize. Atlas, with its agile movements, has a predominantly outdated structure consisting mainly of metal, including titanium, aluminum, and plastic. Weighing approximately 196 pounds and standing at 4 foot 10 inches, Atlas is an imposing robot. In contrast, Optimus Gen 2 proudly boasts a more human-like design, crafted from a combination of 60% aluminum and 40% polyurethane plastic, resulting in a significantly lighter weight at 138 pounds. Furthermore, Optimus 2 excels with its superior payload capacity of 45 pounds compared to Atlas's 25 pounds. When evaluating a robot's mobility, it determines its physical prowess and adaptability in various situations. Atlas demonstrates relatively impressive physical skills, such as performing acrobatics, jumping, and climbing, mimicking human movements closely. However, its perception relies primarily on pre-programmed computer vision, making it less adaptable to unforeseen situations. Conversely, consider Tesla's Optimus's ability to utilize AI-based perception through 8 cameras and sensors, allowing it to create 3D models of the surrounding environment and understand complex tasks. While Atlas excels in physical skills, Optimus stands out in decision-making and proficient task execution. If we pay attention, we can clearly see that the design of the robot's hands plays a crucial role in its effective object manipulation. Optimus has a hand with 11 degrees of freedom, closely mimicking the human hand, allowing it to grasp objects efficiently using frictional force. Atlas, with 12 degrees of freedom integrated into its forearm, assists in lifting heavier objects but is less flexible when handling objects compared to its counterpart. When it comes to the robot's drivetrain system, it's evident that it influences flexibility, control accuracy, and startup time. Gen 2 utilizes Tesla-designed electric drivetrain systems, providing flexibility, precise control, and instant startup. Conversely, Atlas lags behind as it relies on a hydraulic drivetrain system suitable for applications requiring high force and stability, but may have slower startup times and require more maintenance. Noise emission is a big concern for users, especially if the robot's designed for consumer use. The hydraulic system used by Atlas tends to be much noisier compared to the smooth, quiet operation of the electric motor that Tesla's Gen 2 employs. Continuous noise emission will negatively impact user experience, making Tesla's focus on creating quieter robots an advantage. Furthermore, let's consider the purpose and commercialization of these two competitors. While Atlas is primarily designed for research purposes, Elon's vision for Tesla's Optimus extends beyond research and aims for commercialization. Musk plans to manufacture 1 million Optimus robots with the goal of reducing the price to below $20,000 and potentially increasing it to $30,000 in the future. In contrast, Atlas is rumored to have a price tag of up to $150,000 due to its extended development time and the maintenance requirements of its hydraulic system, with a price difference of at least 5 times and potentially cheaper by 7.5 times compared to Tesla and Boston Dynamics. Pricing's always played a crucial role in the adoption of robot technology. Boston Dynamics' quadruped robot Spot is sold for approximately $774,000, while humanoid robots like Atlas typically have a starting price of around $150,000. If Tesla's Optimus achieves an affordable price point, it could revolutionize the robot market and make advanced robot technology more accessible to many more consumers. But only by next year, 2025, when Optimus officially hits the market, it might immediately dampen Atlas's sales figures. Tesla Optimus is renowned for its being created by Elon Musk and his team, as part of Tesla's vision for automation. The robot is designed to handle unsafe, repetitive, or mundane tasks, aiming to revolutionize the labor force. Optimus is built to adapt to and easily navigate the human environment. It can manipulate tools, carry loads, and perform various manual tasks. Initially designed for use in Tesla's factories, it also has the potential to support daily chores and household tasks. Meanwhile, Atlas is known for its agility and ability to navigate complex terrains, capable of running, jumping, and performing gymnastic maneuvers. Primarily developed for search and rescue missions in harsh environments, it is also proven useful in construction and transportation, showcasing its versatility as a multifunctional robot, but this is still under development and requires further adjustments. Another strength that is hard to beat is Optimus's smooth movement and its ability to easily navigate tight spaces. It handles objects carefully and can perform various tasks, from simple lifting to complex assembly, making it useful in both industrial and household environments. It may lag behind its counterpart Atlas in terms of agility and noise levels due to Atlas's high agility, but a significant advantage is its ability to run, jump, and perform gymnastics, making it ideal for traversing rough terrain or obstacles, similar to those commonly encountered in search and rescue missions or on construction sites. Not stopping there, when Elon wants to direct Optimus to use Tesla's AI quickly to learn and adapt to new environments and tasks, improving over time. That makes it a flexible addition to both workplaces and homes. With a slightly different orientation, Atlas uses advanced AI to interact with and learn from its environment in real time. This learning ability enables it to handle complex and unfamiliar tasks necessary for working in dynamic environments. Although not officially launched on the market yet, Optimus is highly regarded as a flexible, capable of working not only in Tesla's factories but also in other industries. It can manage inventory, assist in packaging, and handling maintenance tasks in commercial environments. Especially in the near future, it's expected to help with daily household chores, especially in elder care. It's designed to easily integrate into various environments, streamline tasks, and enhance safety. But for Atlas, despite being highly acclaimed in challenging environments for search and rescue missions, where it can navigate through rubble and access hard-to-reach areas, it's also useful in natural disaster areas or construction sites, performing tasks like inspections, material transportation, or complex repairs. Its advanced durability and mobility make it a vital tool in high-risk situations, but this is only what the manufacturer is aiming for, and it may take longer to achieve. Of course, there are realistic limitations, such as short battery life and the need for frequent maintenance, which may limit its use in long-term tasks. Additionally, the biggest drawback we mentioned earlier is the cost of Atlas, and its practicality in the real world is often questioned. It excels in controlled experiments, but faces challenges in real-world situations with many unpredictable factors. Therefore, as it has been researched and developed for quite some time, Optimus is still the more prominent name and seems poised to prevail due to the various factors we analyzed above. What factors contribute to Unitree H1 not being considered a rival to Optimus Gen 2? Not only does Tesla's homegrown robot outshine its rivals in the same field, but when it comes to a reputable manufacturer like China, Tesla's robot still demonstrates many superior advantages and does not consider H1 as its competitor due to various factors. If Unitree is famous for its four-legged dog-like robots, then the December before last, they introduced the bipedal robot H1, describing it as one of the most powerful humanoid robots in the world. At that time, H1 stood 1.8 meters tall, weighed 47 kilograms, and can carry loads up to 30 kilograms. Each leg consisted of 5 joints, distributed at the hip, knee, and ankle. The arm had 4 joints placed at the wrist, shoulder, and elbow. The robot could capture the surrounding environment from a 360-degree perspective through the Intel RealSense D435 eye sensor cameras mounted on its head and LiveVox MID360 LiDAR module. The data from these devices was analyzed in real time by the dual Intel Core i7-1265U processors. Now, let's look at the design of the Optimus Gen 2 that Musk has created, truly sleek and eliminating the industrial feel to appear more streamlined. Inspired by the Model S, it seems to move faster and enhance balance, making it a mobile and stable device that's 56.7 kg, slightly heavier than the H1 at 47 kg, with a 15-hour battery life when operated wirelessly. However, its mobility currently lags behind that of Optimus Gen 2. In terms of strength and performance, Optimus Gen 2 aims for efficiency with a Tesla-designed battery promising durability over time. However, H1 boasts considerable strength for wireless operations and impressive power given its size. While Optimus Gen 2 leads in speed with a 30% increase, H1 shines in strength, being able to lift heavier loads. When it comes to strength and payload, the Gen 2 object can lift up to 15 kilograms, suitable for tasks like carrying groceries or tools, while H1 can lift a whopping 30 kilograms, ideal for construction or industrial applications. Its powerful motors and joints allow it to perform heavier tasks. In terms of flexibility, Gen 2 excels with new steeper motors and a high-speed transmission system ensuring precise motion and responsiveness. Equipped with tactile sensors, its 11 degrees of freedom of movement helps it adeptly handle delicate tasks. While H1 may not match Optimus in agility with its 24-degree flexibility, its freedom of movement across its joints provides remarkable flexibility, making it a reliable companion for tasks requiring complex motion. Regarding AI and autonomy, Tesla's accurate Dojo supercomputer and second-generation AI support enable learning and adaptation in real-world situations. Although autonomy concerns still limited, H1 uses an open-source AI platform offering flexibility for customization, though not as advanced as Dojo, but it demonstrates impressive autonomy in various forms. In motion and agility tasks, Gen 2, although still under development, promises to improve agility with a 30% increase in movement speed and more flexible arm and neck movements. However, it still shows instability in walking motion. On the other hand, H1 demonstrates superior agility, easily navigating through complex terrains and performing impressive jumps and flips. Spatial awareness is supported by 3D LiDAR and camera systems, ensuring accurate navigation and dynamic motion, making it stand out in performance in complex environments. Let's consider the environmental and functional aspects. These robots serve different purposes. Optimus Gen 2 is designed to be flexible, capable of supporting manufacturing, construction, and even household tasks with integrated AI, promising adaptability and learning. On the other hand, the uniqueness of H1 lies in its focus on industrial applications, performing heavy lifting tasks and even collaborating with humans. When it comes to the crucial factor of price and availability, Optimus Gen 2's price has not yet been disclosed, but Elon promises affordability with expected costs potentially below $20,000. In contrast, H1 has a starting price ranging from $90,000 to $150,000 in 2025, but is currently available for early adopters willing to invest in advanced technology. So, being 4.5 times cheaper than Unitree H1, Tesla Gen 2's got a significant advantage. Yet the competitor is not yet optimized. Although both Gen 2 and H1 represent pioneers in the field of robot manufacturing, each type has its strengths and weaknesses, ultimately shaping the future of humanoid robots, and these players are leading an exciting race where H1 still needs upgrades and changes to compete with Tesla's humanoid robot. Seemingly, something that H1 can confidently boast over Tesla's bot is when Unitree Robotics announced that their humanoid robot H1 had set a speed record of 11.9 kilometers an hour. That's 5 times faster than Tesla's Optimus. In a video released on March 1st, Unitree Robotics, a Chinese robot startup, showcased the latest advancements in their H1 Evolution version 3.0 model. Last year, H1 garnered attention for its balancing ability, operating on complex terrains, enduring strong kicks from humans, and carrying heavy loads. In the latest version, Unitree Robotics stated that the Evolution version 3.0 model has broken the speed record for humanoid robots. It can move on flat surfaces at a speed of 3.3 meters a second. That's 11.9 kilometers an hour. Meanwhile, Tesla's Optimus is achieving a speed of 0.6 meters per second. In 2022, the two-legged robot Cassie from Agility Robots out of the US set a speed record by completing a 100-meter dash in 24.73 seconds, with an average speed of 4 meters a second, equivalent to 14.4 kilometers an hour. However, at that time, Cassie looked quite basic with just a pair of legs and a head, not yet considered a humanoid robot. Not only stopping at fast movements, the Evolution V3.0 also demonstrates agility in climbing up stairs and down in multiple directions and dancing to music. It also coordinates the entire body during jumping. In the video, Evolution version 3.0 can jump as high as a human. According to analysts, performing a standing jump is more important than a performance, as it demonstrates that H1's legs have the ability to coordinate with other parts of the body smoothly and maintain perfect balance. The leg system operates on domestically produced M107 electric motors in China. Western humanoid robot models like Boston Dynamics Atlas can also perform jumps, but still rely on cumbersome hydraulic drive systems. Therefore, creating legs like those of Evolution V3.0 is considered a major step forward in the robotics industry. How does Tesla Bot maintain its lead over the Figure F1 robot figure in the competitive landscape? When comparing Optimus with Figure F1, it's clear both robots share similarities in appearance and purpose. However, Optimus benefits from significant resources, expertise in AI, and Tesla's track record of innovation. On the other hand, F1, as the first versatile humanoid robot on the market, showcases pioneering efforts in AI robotics by a startup company. The competition between these two robots highlights notable advancements in the AI and robotics world. In a parallel move, Microsoft and OpenAI are reportedly leading a $500 million investment round for F1 AI, a leading humanoid robot technology. Figure F1 has garnered attention for its advanced capabilities, learning human actions through AI technology. Collaborating with BMW to deploy humanoid robots alongside humans in assembly lines signifies a broader trend among tech giants, reshaping the boundaries of AI-supported robotics to transform the job market and redefine daily life. As Optimus Gen 2 takes its initial steps and Figure F1 brews coffee alongside humans, the collaboration between these tech giants foreshadows a new era of non-human labor, promising both challenges and opportunities in the evolving landscape of intelligent agents. Tesla Bot and Figure F1 are humanoid robots designed to perform tasks in human environments. Optimus, standing at 5 foot 8 inches and weighing 160 pounds, can carry up to 45 pounds and move at a speed of 5 miles an hour, while F1, standing at 5 foot 6 inches and weighing 132 pounds, can carry up to 44 pounds and move at a speed of 1.2 meters a second. Both are designed to undertake hazardous, repetitive, or undesirable tasks, while Optimus focusing on factory work and Figure F1 emphasizing autonomous learning. Both bots are still under development with promising capabilities. For the robot, it stands at 5 feet 6 inches tall, 1.7 meters. Figure F1 weighs 132 pounds, 60 kilograms. It can carry about 44 pounds, 20 kilograms. It can operate for about 5 hours and has a maximum speed of around 2.7 miles an hour. That's 1.2 meters a second. The robot is designed to mimic the human body as closely as possible. F1 has arms to open doors and use tools. It also has arms and legs to allow for efficient movement, climbing stairs, and, as we've seen, carrying stuff like boxes. We can see Tesla's humanoid robot Optimus folding clothes and shaping a robot, along with the ability to automatically brew coffee, as a typical example of the advancements achieved in the field of robotics. These demonstrations highlight the potential of AI-supported machinery to perform complex tasks and signify a new phase of progress in this field. On the other hand, progress in this field is illustrated by Figure F1's robotic arm, a collaborative effort between Figure 1 and AI. This indicates the accuracy in the latest automated movement trend, where robots can engage in natural conversation, identify objects, and perform tasks flexibly. This marks a significant milestone in the development of robots, while Optimus seems to face challenges in its development journey. Furthermore, progress in this field is exemplified by Figure F1's robotic arm, a collaborative effort between Figure and AI. The small image of accuracy in the latest automated movement trend is a recent video showing Figure F1 engaging in natural conversation, identifying objects, and performing tasks with a red apple on a plate. These revelations indicate a dependence on remote control in some tasks, raising concerns about the autonomy of Optimus and its actual progress compared to Figure F1. In a current context, Figure F1's efforts to optimize table dishes and its operations through end-to-end neural networks are prominent, while Optimus seems to rely on remote control to complete some tasks. The absence of remote operations in Figure F1 further reinforces its superior technology. The showdown between these two robots demonstrates the independence of each team and the ongoing progress in the field, which can be attributed to the formidable team including individuals from companies like Boston Dynamics. Unwavering pursuit and innovation have propelled Figure F1 to the forefront of the robotics field. We hope you'll experience the utmost relaxation after watching this video. If you do, please press the like button and join the Tesla Car World community by subscribing to our channel. Hit the notification bell icon to stay tuned for any fantastic videos coming your way. Your feedback and time are highly appreciated. Thank you for watching, and we look forward to seeing you soon. Until then, stay safe and enjoy.